All right, the first jig I want to show is tapering jig, and I use it only for tapering legs, but you can taper anything on it. It's very, very versatile, much more so than those little things you buy that are made out of metal with a one thumb screw that locks them. This is a Steve Latta design, and first thing you'll notice about it is it has this piece here that's loose. There's a piece here, a piece of oak. Put it together like so. Clamp it to my fence. That collectively makes the jig so that it can't tilt and fall off the far end of the table. So it's totally there for safety reasons. Now, as to how the jig itself works, this sets the amount of taper, and I'm setting it to cut exactly on this edge right here, and I do it by moving the fence in and out. Once this gets boogered up, I can move it over 1/8 of an inch and cut a new straight line and continue using the jig. Now, this is a leg, one of many I've made. This is just a sample, and I'll show you how it works. You lay a blank on here. You line up a piece you want to cut. For instance, if I wanted to taper this, whatever I want to taper off, I'll line it up with this edge. And then I set this like so, tighten these up. Then I can cut multiples of that exact same taper if I don't move this. Let's say I wanted to taper, I want to make a leg just like this one. Have a block on the end with a screw in it to hold this end so it can't move around. Tap it in with a hammer or whatever else. It takes very little to hold it in place. Set it on this edge here and move this fence here, put it right there. Clamp it down, move the whole thing up to the saw blade. And it'll taper it just like so, all the way down. Cut as many as you want to, and they'll be exactly the same on two sides only. If you're going to cut a third, most legs are tapered on the two inside corners. So this side over here is square to the top of the table. If you're going to taper the third and fourth sides, you got to change the setup, and that's very important because you can screw things up. What we have here is nothing more than a tall fence. It's made out of phenolic plywood. Now, this stuff is very expensive. You get it at Woodcraft, it's like $30 for a quarter of a sheet. But you don't need much. And I made it out of this because I wanted it to last a long time. It straddles my fence here, so it's riding on the table, on the tabletop. There's no play in it, left to right. You can make them so they ride on your fence, but I just chose to make this one so it rides on the table. You can turn it around if you don't need it this tall, if this distance here, if that works for you, you can reverse it and run it the other way. There's a lot of different things you can do with it. For example, if I make a picture frame and I glue it up and I want to miter the corners. How do you miter? Let's say it's 2 feet square. Well, I screw one of these over here and another one over here, and you can see the screw holes where they've been there in the past. I create a 90-degree cradle to hold that picture frame, slide it over here, cut a slot for a miter. Just rotate it around, cut all 4. So it's infinitely versatile this way, up and down, raise the blade, lower where you put these, but this stays constant. I can also use it to cut tenons. I put this fence on here for a tenon. I want it to be perpendicular to the table this way and this way. So you need to check all that. This thing stays pretty well perpendicular in this direction. But every time you put a vertical fence on in this direction, you have to check it for square in this direction. I can put on a wide fence or a narrow fence. I can move these Destaco clamps anywhere I want them to hold whatever it is I'm clamping in place. Put it in here, clamp it. Very stable. It's not going to move at all. Turn it around and cut the other side, or put two saw blades on at the same time and cut both of them at once. Put two saw blades on with a shim between them to dictate the width of the tenon. I recently made a flag case, and this 22.5-degree miter on a flag case, I don't know any other way to cut it. So I can put this piece of molding in here like so, clamp it in place, tilt the blade 22.5 degrees, cut miters all day long. Very, very accurate. I tested two of them with plywood to get it honed in exactly where it needs to go, because the joints on a flag case are going to be looked at very closely. You want to get them dead on. And this does it. Very, very versatile tall fence. You can make it as tall or as short as you want. None of that matters. The only problem with it is it takes a little room to store it. So that's the tall fence jig. So what we have here is I've made a number of these little octagonal boxes, and they can be made so the footprint is different from this, but still octagonal. These are 45-degree cuts here. The contrasting wood right here is let into a saw curve. Now all of that's done before you cut the top off, and of course before the hinges go on. So how do you cut that? We have to make it, I don't know any other way than to make a jig for it. So what I have here is two white oak runners that fit in my slots, and it looks like it's a little tight right now because of the weather. What I have here is a cradle that this fits into, just like so. It's trial and error to make it get where it works, but when it fits, and it'll cut them all day. Just push them through. I don't clamp it in at all. I just put them in there and push it through, pick up the box and bring it back. Cut all 8 of them one time. Dedicated jig, I don't know of any other use for it, but it cuts that very, very well. These joints are mitered right here. And for durability, you need a spline that's hidden, or I chose to expose them on this side with a contrasting wood. So how do you cut these? It needs to be a flat bottom. If you have a saw with anything other than a flat bottom, you're not going to be able to hide that. I made a jig for that. I planed this wood down so that it fits in the miter slot. So it's sliding very well now. I checked it out the other day. I put the box in here like so, and then I will clamp a little stop here so that I can cut 4 of these things that'll be the same in the same plane in this direction. Then I can move it over, cut 4 more. I can raise the blade up or down to control this dimension here. Now it's dedicated to a given blade. So if you're going to cut wider ones or narrow ones, you need to make one for each blade, or it's going to fit the widest blade you've ever put in it, and you'll get tear out if you try a narrower or thinner blade. This one is for cutting miters like you're cutting a picture frame. And depending on what I'm doing, I'll put Destaco clamps here, stop blocks on the end, so you can cut multiple pieces the same length. Very accurate miter, but you do need to clamp it down. Whatever it is you're cutting, you need to clamp it down, because any little movement at all, you're going to get something other than a good tight joint. Now this one has purchased miter slot bars on it. So here's a 90-degree sled with oak runners on it, and they work as well as the purchased ones. You sometimes have to take a little off. Usually sandpaper's enough to account for the moisture uptake or when it gives it up. And I have larger ones and smaller ones, and ones that are dedicated to different blades. It needs to be dedicated to a given blade, or it's going to fit the thickest blade you've ever used in it. And if you use a thinner blade, you're going to get tear out that'll be objectionable. Right on the sled, which blade fits, because you will not remember and you'll screw it up. Now, this sled rather has no runner. What it has is screws on the back side that fit miter gauges. Put a miter gauge on both sides and use the miter gauge. And you can also put an extension on here if you have something longer and you need a stop block over here to accommodate something long. It's just another 90-degree sled that has a 45-degree bevel in it. Like if you're cutting a spline, a hidden spline in say a box side or whatever. This is much more accurate than doing it on a radial arm saw or anything like this. This is much more accurate. But again, I wrote the blade that fits the sled, write it on the sled so you can pull it out and use it again. And by the way, when you're tilting the blade, those Dixie Digital angle gauges, I usually don't trust electronic things, but I've checked those out every way from Sunday. Those things are dead on. At least the one I have is. You can rely on the angle you're reading. Making banding requires, if you're going to cut them on a table saw, you cut hundreds of small pieces that must be the same size. So how do you do that safely and successfully? That's the question. What I have here is a sled dedicated to that. Now, because when you do this, when you make this banding, there's a whole lot more wood goes to sawdust than goes to the banding. So I wanted a thin kerf. This kerf is 1/16 inch thick or wide. It's a 1/16 inch blade, which is what 2/3 the thickness of your typical thin kerf saw blade. So I put in a throat plate that's 1/16 inch, and then I have a 1/16 inch kerf in my blade in my sled. How do I cut these pieces successfully and keep them the same length? If I clamp this stop right here, push my stock against that stop, cut it off, the offcut, real small, in this case, maybe a little over 1/8 of an inch. It's going to be loose, it's going to be lightweight, and when I pull it back, it's going to probably fly back. It'll destroy it and hurt me or both. What I have here is a stop this is a Steve Latta stop. It's an L-shaped piece of wood that slides right here. This is another little block that in conjunction with this block I put right here, and I'm going to put a piece of paper between them so it'll slide. And I'm going to clamp. Now this little block here has sandpaper on the back so that when I clamp it to my fence, it'll stay where I put it. And it has a screw in the end, and I'll get to why it's there in just a second. So I'm going to put this stop right here, and the screw head is against this surface right here. And I move the whole thing to where I want it so it cuts the size piece that I'm looking for. Then I clamp it in place. Now it slides freely. I can push the stop this way, push the stock that I want to cut this way until they hit each other, hold it in place, move this out of the way, and cut off a piece. There's plenty of room for it to fall away from the blade without becoming airborne. Push the stop block over here. The piece I want to cut's against it. Get up to the blade, cut off the piece I want, move the block, pull it back. I pull it back far enough that the blade has disappeared on that side. There's no way I'm going to cut myself in here. The blade is not exposed in here because I pulled it back far enough. If that's too thick, I go right over here and take a screwdriver. Very sensitive thickness adjustment by running that screw in and out. I can run it out 1/1000th of an inch, or thicker or thinner, whatever I need for them. You can cut them off a 1/16 of an inch thick if you want to. Very safely, as many as you want, and they're, by and large, they're dead on. So I cut it this way. You can take a dozen of them, lay them over, stack them up, they're all flush on the top. They are the same thickness. Very, very accurate. The hinges on these boxes, regardless of what it looks like cosmetically, I use the same hinge on all of them. Same hinge on these boxes. A Brusso JB101. What I have here is a jig that helps me mount these hinges. So here's one of the hinges, and it fits very tightly into this notch. The notch indexes the depth of the hinge in this direction, and the width of it, there's no play in this direction. Very tight. Then I have a fence on this end that positions the hinge along the back of the box. So I got one on this side for one box and one on this side for another box. Maybe this one fits this box. Yeah. See, that goes right there. The other notch on the other side fits this box, like so. Now, how do you use it? Well, the way I use it is decide which one of these you want to use, or cut another one, locate it wherever you want it located. But I want both hinges to be the same distance from its nearest corner. So if this is the back of a box, I put this on here, index it all the way that way, clamp it in place, and then you have a choice to make. You can use this to guide a router with a bearing on the shank end of the cutter, flush cut router bit. And what that'll do is hog off most of the material and control the depth, which is the thickness of the hinge itself. It takes a while to get that adjusted, but once it's adjusted, it does a very good job of controlling that depth. The other way of doing it is what I normally do, is I just take a marking knife and mark these lines. The ones on the side I mark with a knife, and the back one I mark with my marking gauge. I'll set it to this depth, like so, and then mark the back of it. Then I'll use a pencil if the wood is walnut, I'll use a white. I want something I can see. Then I will take a router, just a straight flush cut router bit in a trim router, and hog out that material freehand, getting up as close as I dare to the lines I just marked. The depth is right, because that's where I set it. And then what I can't get out with a router, I cut out with a chisel. I've made a lot of these ornaments. Made well over 200 of these things. And this is a turning project, but it's very much a joinery project. In this particular one, the dark pieces are same thickness, they're not tapered. But the maple is tapered, and the taper has to be dead on or it won't close when you clamp it up. So here's how I do it. Here's one that's cut in 32 pieces, and that's what it looks like. So if your angle that you're cutting them at, if it's off, it's multiplied 32 times. So it can't be off. It's got to be dead on. So this jig right here is what I use for that. This is called a Dubby. Peachtree Woodworking Supply is the only place I know that sells them. It has a fence, moves like so. It has degrees marked on here, and it has 5-sided box, pentagon, 4-sided, which would be 45 degrees, 9 sides. I made one time with 7 sides, just so nobody's ever done it before that I know of, just to see how well this thing works. This scale is cut with a laser, and once you get that scale in the right place, up and down this way, it's in the right place for any angle you want to cut. So let's say I can set it right here. This will make an 18-sided box if I put it right there. And I've set it on the bottom edge of it's a wide black line. I set it on the bottom edge. The top edge is not where it wants to be, because that's where I set it. I can cut 18 pieces, put them together with tape like this, and see how well it fits. It's trial and error, but once you get it set, cut as many as you want to, and they'll be dead on. It has 3 screws in this, has 4 screws in here, and the hole in the metal is slotted. So that's the calibration. You slide it back and forth, make some cuts, see if it's off, which way you want to move it, tighten them up again, trial and error, take 3 or 4 times, but when you get it right, it'll stay there. I've never moved it after I once calibrated. If you want to cut long pieces like a picture frame, you want a 7-sided picture frame, they don't have to be the same length either, just 7 sides. You can make it with this. So that's how that works. I have one of those Inca things. I like this much better. This costs a third of what that cost. And this is better.
Hi, I'm Art Sanders, and welcome to my shop. Today we're doing a presentation on jigs, and I prepared a few notes. What came first, the challenge or the jig? In woodworking, we're always challenged to do things repetitively with consistent results. So what is a jig? Well, according to Webster, a device used to maintain mechanically the correct positional relationship between a piece of work and the tool or between parts of work during assembly. As woodworkers, our first jigs were our hands. We held our piece, used our tool to cut the piece, and that worked for a while, and then things got more complicated and it got more interesting. We built workbenches. We fitted them with vices, with clamps, with wedges early on, and they became our third hand. So the jigs that we're going to take a look at today help me solve some of my woodworking challenges. And the first one we're going to look at is a miter hook. This jig is made up of a piece of plywood, Baltic birch. I use a lot of Baltic birch. Doesn't have to be. Could be MDF if you prefer. Something stable. A piece of, again, plywood to hook on your bench, and a fence. And this fence was put on here, and then I used actually a square to do a square cut here and a 45 cut here, so that I could quickly come over with a Japanese saw and cut a 45-degree angle if I needed, or square up and in. And you say, okay, that's good. But you know, you can only get so far with saws if you're looking for perfection. So the complement to this jig is another jig. This one, Mike Pekovich, it's copied off of one that he had in Fine Woodworking. And I use this all the time. It's just dirt simple and it's really cool. It's all based around a $3 speed square. You cut a groove to fit your 1/4-inch speed square side. The fence and the hook on the back, again, this is a piece of hardwood that I've let in with a dado. That hook's on the bench. The fence has a little bit of slop in it, pinned on this end, and it's got a adjustable knob on this end that I can put my speed square in here, square it up, tighten it down, and now I've got a pretty perfect 90 that I can use for running plane across to square up and in. So you say, well, that's cool. Okay, well, it's got a second trick here. Because I've got a speed square that I can let in here, I put a fence on it. Again, it's rabbited out on the back. Okay, so I've got an edge here. Slide it up. You've already made that 90, so this is, by definition, 45. And I now have a way of truing up a 45 for a perfect fit. Now, if you're doing trim work or whatever, and that's where I ended up with these two, I actually did a bunch of trim work at my son's house, and rather than transport up a miter saw or something, which aren't that accurate anyway, I was able to do all the trim work with this and get really good looking trim. I usually keep some playing cards around. I got some there. But you could put a playing card in here, and you can adjust this at about 11 thousandths at a time, and you can actually change the angle, you know, to get that perfect fit for your miter. These are great for smaller pieces. If you're trying to do something on a table saw or a miter saw with a small piece, this is much safer. And you say, well, it's not exactly fine woodworking. No, but it's woodworking, and we all enjoy a challenge. And we were doing hardwood floors at my son-in-law's and my daughter's house, and we came to the stairs, the staircase, and it was one of those deals. I think they wanted $5,000 to have a pro come in and do it, and of course it was, Dad, do you think you? Yeah, we can figure something out. So I came up with this little jig. Again, pretty simple. Piece of hardwood, that I ripped a dado in and fitted a couple of movable fences. Again, ran on the router table with a 1/4-inch bit, bolted it through so that I could make an adjustable knob on it. And then I put a couple of end pieces on that are again adjustable. So no matter how badly the wall is fitting, I can adjust this to fit the wall on one side, fit the wall on the other side, lock this all down. I can take this back to my stair tread now, mark it, and then if you do have a miter saw, this is where they come in handy. You can set it up to that perfect angle and you can get a nice tight stair tread. Anybody that builds bookcases or has the opportunity to put a dado in a piece of plywood to make a shelf or actually cabinet tops, bottoms, whatever. Pretty simple to make. You can spend maybe a couple hours. A couple of pieces of plywood with a hardwood nose on it. And those noses, I started off, I think these were 1/2 inch. You could use 3/4 inch, whatever. But glue them on, take them to your bench, put them together, and use your hand plane to make them parallel to each other. So just as if you were going to glue them together. Get it nice and tight. After you get done with that, you have the two fences here. The fence is attached on this side. So you want to make sure you square up, especially this one. You want to square this up to this fence. This side is movable. After I get that done, my two fences, again, 1/4-inch router bit on the router table to cut the groove. Push it together, lock it down. This particular jig is set up to run a 1/2-inch bushing on the router. I didn't put the router on here because I think it's easier to see what's going on without the router. And this is a 3/8 inch bit. Set it for about, this was 3/4 inches wide, set it for about a 1/2 inch depth, so that you're going to leave a 1/4 of an inch on the bottom, and take and run your router up one side and back down the other. Now, what did that do? If you could get in tight here, you could see that I actually just cut a little rabbet into that hardwood nosing. And I now have a perfect fit for this particular bushing and router bit on this edge here. I've got a little 1/4 inch ruler, basically, if you want to call it that. And I have a little rabbet in there that you can use to line it up on your carcass part. You take your cabinet side or bookcase side, whatever. You have it marked out for however many shelves you have. Take your plywood that you're using, and I can come in here and loosen up my jig. I can put my workpiece in here. Now I just clamped it against my little edge here. So now I've got a perfect fit on my plywood, and you can see it's nice and tight. Okay. Now, flip it over on my cabinet part, line up my little edge there with the line that I've drawn already, and I now have it square to the edge of my carcass, and all that's left to do is fire up the router, drop my bit down far enough that I'm cutting, if I want to cut a 1/4 inch dado, you can, or a 1/2 inch dado, into usually about 3/8 is what I shoot for on a 3/4 inch piece of plywood. And put it in your bushing. You run up one side of your guide, back down the other side of your guide, and you now have a dado that will snugly fit your plywood. The mortising jig is made up of several parts. I have a couple of fairly hefty fences attached to a 1/4 inch piece of plywood. I have some dados cut in, or actually grooves, I guess these would be. Grooves cut into the plywood for my adjustment screws. These are adjustable, the fences. And I have a pair of fences up on top here, okay? So, how do I use this thing? Again, this is, I think, a 3/8 inch bit. So say I was going to put a 3/8 inch mortise into a table leg. I would take the jig, I would draw a center line on my leg, and I would drop my jig onto my center line. But I have center lines drawn, and I would tighten these guys down. Now it's just a simple matter of, you could put some stop blocks on here if you like, or you can eyeball it. I have marks on my leg usually that are my stop points. Put your router on with your bit, set your depth for whatever you want, okay? Usually I take it in a few bites. I like going about 1/4 of an inch at a time. Plunge router, plunge in on my line, come back, plunge in on my other line, okay? Come back, clean out between those two, drop it 1/4 of an inch, and meanwhile this is doing all the work. I'm just running the tool, okay? You get done, you got a nice clean mortise with rounded ends that you can either take a chisel and square up, or I've done it both ways. You can take your tenon and actually round it over to match your bit, and you've got your mortise. The big challenge for me was to come up with this curved section that fits your derriere. So again, I went to the internet, started looking, and I found some jigs that were used to carve these out. And I also found out that what I really wanted here was a 72.5 inch radius, which we'll have Jim test out the seat in a minute here. But I found that that was probably the most comfortable for a lot of people. So to get the radius, piece of scrap plywood ripping, put a hole in it, put a pencil in it, measured out 62.5 inches, and made a mark on a piece of plywood, and okay, that was my template. All right. Now, how did I get this consistent results on 4 stools? That's where this comes in. This jig, a little more complicated, but really not all that complicated. Remember early on I said that we started using wedges and stuff for holding our work. Well, this actually uses wedges, okay? And if you can imagine this seat setting in here, and I wedged it in, so it's being held tight against the sides, and this is my reference fence here. So this is all holding this tight. The jig itself, piece of 3/4 inch plywood, couple of fences made out of 3/4 inch plywood with a small lip in here, another 3/4 inch piece. I think this was probably about 2.5 inches. This is about half that. So now I've got my workpiece locked in, so I'm not worried about it going anywhere. Now how are we going to cut that curve? My 62.5 inch curve I laid out on a piece of plywood. I took it to a bandsaw and I cut the curve. And I saved the cutoffs, okay? Probably hard to see, but that has the same radius on it as the radius on my track, okay? A little bit of work with spoke shave, sandpaper, whatever you got to do to get this smoothed up and get your curve consistent. And I attached it then to 2 pieces of plywood, which are attached at the front and back to a couple pieces of pine. And I now have a sled. Took my router base plate off, used it to measure where my screws were going to go in, cut my hole. A little bit of paraffin wax to make it easy to slide. And then the last thing is you say, oh, Art, you're going to be there a long time. Well, yeah, it did take a while. But again, Woodcraft, Rockler, Highland Hardware to the rescue. I think this is a 1-inch bit. So I could take and put my plunge router on here, take it down 1/8 of an inch, 1/4 of an inch. You'll have to kind of play with it to see how much you want to take off at a pass. But now I'm able to run that bit consistently on this 62.5 or 72.5 inch curve. The last part of the jig, I don't know if you can see this, Michael, but whoops, sorry about that. But I put some lines on. Here, okay, and they're 1/2 inch apart. And I put a line on the center line of my sled, so when I'd make a pass, I could move it over 1/2 inch exactly, bring it back 1/2 inch, bring it back, and kept going. Oh, here it is. I'm touching it. Piece of wood with a dowel rod, okay? And I could take measurements at different places to see how deep I was, okay? And then try to match it up to the other side.
All right, hello everybody. My name is Kevin May. I'm a novice woodworker. Been playing around with woodworking for about 10 years since my son got out of high school. You're in my shop in my basement, and we're going to start today's discussion about a circle cutting jig for the bandsaw. You see a lot of these designs on the internet. I took everything that I could see and made my own little interpretations to it. The jig requires a 3/8 hole drilled in the bottom edge of the piece that you're trying to cut the circle on. You can see that it's got the T-track groove or a straight groove that aligns with the groove in the saw. And through this slot, the alignment here is there's a T-slot that allows adjustment to change the radius of the circle that you're cutting. So today we're going to cut a 13-inch diameter circle out of this 13.5-inch square piece of plywood. I've already marked the center in the plywood, so you get a 3/8 bit, not all the way through, but about 3/8 deep if you have enough material. My pin sticks up about 3/8 high. I may be a little short, but it works fine. Align your T-slotted groove with the T-slot, and of course my screw hit. I'll slide it out. You grab your tape measure from the saw to the center of the pin. Will be 6.5. That makes a 13. I can tighten the wing nut on the bottom. Now I make a lot of larger Lazy Susans, and the weight of the Lazy Susan hanging out on this side will cause this to tilt up. So what I've done is I've got me a stop that also acts as a hold down on this side of the template, and I clamp it down, and this acts as both the hold down and the stop. I've got this size slot in here, holds down this end of the template, and it acts as a stop when you push it up against the stop. The most difficult thing about this jig is getting this hole on this pin. The trick here on this template is that because it slides, the distance here is greater than your cut radius. Some of the simplest circle jigs don't have that. Here's where you start. You can start in the cut here. You have a circle. But this is an XY table that you can buy from MSC or other places. I mean, you can go online and you see all of the table that you can add to your drill press, and they're all great. But I love this little simple vise in my XY table. I use that constantly. I put my mark on it, clamp my piece in, and I can move it to align that mark under my drill bit. I mean, this is a metalworking XY table, but I use it for woodworking. If I want to cut a slot in my wooden piece, I can get one of the spiral bits here, plunge through and cut a slot. It works great for that. You know, it's like the slot in the bandsaw circle jig. That's how it was made. I make crayon holders. I make and sell a lot. All this tooling cost a lot of money, and I didn't have money sitting around, and I needed something to do, so I started selling stuff, cutting boards, and we'll get into cutting boards in a minute. But I was at these craft shows, and all the women and families are there with their little children. What can I sell? And I came up with crayon holders. I make all different type shapes of animals, cats, whales, fishes, turtles, trucks, whatever. But you have a series of holes that you have to drill to put the crayons in. It's very monotonous in the moving from place to place. This table moves along a linear slide, and I've got a series of holes at a preset spacing. And so I can just go from spacing to spacing to make the one offset for the others. 1, 2, 3, 4, 5, 6 crank. Pull the one crayon holder out, put the next one in, and I'm back to going again. So like I say, I have drilled 10,000 holes at a bare minimum, and that little template just allows me to go really, really, really fast. Or when I want to just have an open table, I have this piece that I sit in there, and I can drill on top of that. Well, this is a little bit larger centering vise, and so I mount it underneath the drill press, get it aligned on center, and I can move it in and out. And then another thing I was able to do, here's the jaws that come on the standard centering vise. Well, they weren't wide enough, so I had these things made to carry, so I can go from this width to this width to this width. And it extended the width of the centering vise, because I think this centering vise was $135. A centering vise that gave me this width of opening was $600, and much bigger and heavier. So this gave me what I needed to make all my little wooden planks with holes that were always on center regardless of the width. Now these a guy could make, because it's just unistrut that you can buy at Home Depot, and a couple of flat bars, pipe coupling. So, and of course my catches on the back, they're made out of wood. So how the Cauls work, I clamp them down in place and I can put them up like so. I have a lot of clamps that I use to glue up the boards. And those of you who are familiar, maybe Woodcraft and Rockler sells these things. Well, the problem is these clamp on all four sides, but you have to leave the tabletop in here until you're finished, until it's dry, excuse me. The glue's dry. I like the Bessie parallel clamps. They're supposedly 1,500 pounds per clamp of clamping force. So I know I'm putting a lot more clamping force than these purchased items. So I machined the thickness of all my boards to about 13/16. And when I hold down this end of the boards, on the other end, you can see they're not flat. That's the purpose for the Cauls, to flatten that group of boards out when you're going to clamp. So that's how I'm going to arrange the boards. When I do anything in here, I don't do one panel at a time for my crafts. I may be gluing up 10 to 30 of these planks at a time. So I do everything in lots to keep my time to a minimum. So the setup of each one of these things, but to use this caul to get that group of boards flat, I lay them down, I pull up the parallel clamps just to kind of get the boards close together. Then I get the quick clamp across here. And that tightened up and is flattening out the tops and the bottoms of that panel. So you get that snug. Sure, it's I designed it to work between 3/4 or probably go down to about 5/8 thick, all the way up to 2 inches thick. So I tighten up the Bessie clamp. I will run my finger along here sometimes and I feel something that the caul didn't get just perfect. I get my rubber mallet, tighten it up. I make sure that these are good and tight. Once they're good and tight, those boards are not going to move. So I pop the Cauls loose, put them up into their little, take this up, I put that onto the floor, I go to the next one. But this is a flat laminate top that I have in this big, I have a fairly large planer, it's a 20-inch planer, and it's got metal drive rollers. And if you go to start trying to plane down thin stuff, it doesn't work well. So by placing this in the planer, the bottom rollers are not in use and it does not snipe as bad and doesn't create a lot of problems. So you can see this is the laminate I put in there. I have this piece of wood that hooks on the front edge of the table of the planer so it doesn't get pulled through the planer. When you're cutting these planks, you want to cut a very consistent length. If not, when you go to glue up the ingrain strip, you've got a tremendous amount of sanding, so you want them very, very consistent. And that's not horrible on a standard sled with a stop. But when you're getting down to the last cut, the width of the plank is very short. So holding the angle critical and accurately to the blade, and some safety items as well, I've got this stop, which pivots into place. You push the plank against it, and then you can release the stop. So it's not the wood is not captured against the blade, and this little device presses down and holds the plank down in place. So the first cut is just to square up the edge of the plank. Pivot the stop in, push the plank up, clamp it, release the stop, and you repeat until your plank is used up. See, we're getting down in the area now where the plank is fairly short, and both making sure that the cut is going to be parallel to this surface and safely holding it in place with your fingers not close to it is where this thing really excels. See, we're only going to get one more strip, but how to make sure that that's perfectly parallel and held safely with your fingers out of the way is just identical to every other cut that we've just made. You can feel across there, you see how equal and parallel the sides were. So this is where, as Jim was asking, what do you do about the patterns? I just kind of mix it up, and so I like that. All right, this is a custom clamp that I've built. 3/4 by 2.5 aluminum bar, 3/4 by 1.5 steel bar. I tap these for 1/2 inch all thread. The modulus of bending on these are about equal. I've got shoulder bolts in the bottom to space it up off the table. I turn it on the table like so. I have this square mounted to keep this edge of the boards square to here. I also have some adjustments. I have spacers made that I can put under so that these planks, when placed in here, are about centered on the clamping force. These clamps are limited to about 15 inches, but that's what I make most of, is boards that are this wide. All the repeating reuse of the components. All right, so it's going to go in like so. So we're clamping on the center of the boards. I snug it up because even with this, it's pulling perfectly on the center line and evenly, and I've got it square, it'll still move. You have to take your time and eyeball and line up. This is really great and better than anything else I found, but it don't do it by itself still. All right, and I've got 5 of these so I can glue up 5 ingrain cutting boards at one time. So that's the slot that the cheese cutting wire will go through. Now we have to drill the hole for the pin. Turn the board upside down and you clamp it down. And what I've done in this board is, from this edge over, is the exact right length for the arm of the cheese slicing wire. And these brass bushings guide my drill bit. I do that a dozen times. I have a long drill bit with a stop collar that I have designed to go in the exact right depth. That's a 1/4 inch drill bit. The wire for the cheese piece is a 1/4 inch. You cannot buy a long carbide drill bit, so it gets very dull. So what I do after I've drilled it with that bit, I get my 1/4 inch carbide and go as deep as I can to make sure that the hole is 1/4 inch diameter now. Put it in, put the wire on, you pop it over, and there is a cheese slicer.